Okay, in goal 4.1, as I mentioned maybe earlier, I don't remember if I said it in this class or not, but when you are factoring, you are doing the opposite of what we did in super goal 3. In goal 3.3, we use the distributive property by taking monomials times polynomials, then we FOILed. We used binomials times binomials, and then we took a binomial times a trinomial. So those questions all started with parentheses, and then they ended up without parentheses. Correct? Yes. I had to think backwards and think if I'm thinking the right way. So now they're going to start without parentheses, and you're going to put them back in. So I could take several of the questions that we had on the test, and the answers, I could make the questions for the next test. Okay? So it's very exactly the opposite, not very exactly, it is exactly the opposite of what we did. The first rule of factoring, which we will emphasize this rule for all goals that we're doing, I will emphasize this rule, is looking for a common factor. And in this case, we want to actually pull out the greatest common factor. Your common factor might be a number, an integer. Your common factor might be a variable. It might be a variable with a power. It might be two variables. It might be all of those things. Okay, so it can be as simple as a number, or a letter, or a combination of that in any form. Okay? So what you're going to see today is completely the opposite of the distributive property. Example 1. First, look at coefficients. So we have 15 and 3. So you're looking to see if there's a common factor to those two numbers. And there is. I can take out a 3. 3 is common to 3, 3 is common to 15. One of the terms has an x, but the other one does not. One term has a y, but the other does not, which means that there's not an x common to both terms, or y common to both. So 3 is the only thing coming out of there. Then my parentheses. Whatever you take out in front gets divided in. So 3 divided into 15 is 5. My x comes down. My sign doesn't change. It stays minus. 3 divided into 3 is 1. And my y comes down. The 1 would not have to be there, but it certainly can be there. When you do a question like this, there are two things you should do now. One is not necessarily with paper and pencil, but at least mentally, distribute. 3 times 5x is 15x. 3 times minus 1y is minus 3y. So if you mentally check and get back what you started with, you're probably in good shape. Not a guarantee you're 100% right, unless you check the other thing. So the second thing I would do is look at what's in parentheses and make sure that there's nothing common to both of these things other than 1. So 5 and 1 only have 1 common, one has an x and a y, so you're done. Okay? So I'm going to do that on all of our examples here. Second example, 8 and 7. There's no common number for 8 and 7 other than 1. So there's no number that's going to come out of that one.
Borgia, sorry for the interruption. Would all students from St. John's Parish please come down to the chapel? All students from St. John's Parish, please come down to the chapel.
Anybody? Need to go? Okay, so x. X is common on both terms. You see x on both of the terms in there. One of them has an x to the second power, and one of them has an x to the understood 1 power. When you take out a common variable, you take out the lower power. So we're going to take out an x to the 1. So power of 2, power of 1. You take out the lower one. So I divide in. My 8, I didn't use it, so just bring it down. If I take x from x squared, I'm taking 1 away, which leaves me the other 1. Plus, my 7 comes down that I didn't use, and then x divided into x would cancel out. And I'm going to double check myself. X times 8x is 8x squared. X times positive 7 is positive 7x. So that's the first thing you should look at. Mentally check that. And then look at what's in here and make sure there's nothing common to the things inside the parentheses. And there's not. So you're good. That's your answer. Okay. Questions so far? Okay, next question. 27 and 18 have a common factor of 3. But if you take a 3 out, it's not the greatest common factor. So 9. It's bigger. It goes into both of them. I take a 9. I have one term has an x squared and the other has an x to the 3rd power. So they both have x. X is common. You take out the lower power. So x squared. And then I divide. 9 divided into 27 is 3. X squared into x squared would be gone, canceled. Sign comes down. 9 divided into 18 is 2. And if I take x to the 2nd from x to the 3rd, so take 2 away from the 3, and you're left with the other 1. And we check. 27x squared, 18x to the 3rd, because remember we add powers, and then nothing common to those two things inside there. Okay, next example. 7 and 14. So 7 is common to both of those. X is present on both. So one has an x to the 3rd, the other has an x to the 2nd. So x to the 2nd, the lower power comes out as the common factor. They both have y's. We have a y to the 4th, and we have a y to the 5th. So I take out the lower 1. And I divide. 7 into 7 is 1. X to the 2nd divided into x to the 3rd, so take 2 from the 3, leaving you 1. The y to the 4th and the y to the 4th would be gone. Since there's an x there, that 1 is optional. Plus, 7 into 14 is 2. X squared into x squared would cancel completely. Took it out already. And then y to the 4th out of y to the 5th. So take 4 from that 5, leaving you the other 1. Distribute mentally just to check yourself. And then look for common factors inside, and there are none. If you find common factors on the inside, then you don't have a big enough thing on the outside. Ten and 9 and a 1. Nothing but 1. So no numbers coming out of here. X squared, x to the 1st, x squared. So I'm going to take out an x to the 1st. Y to the 3rd, y to the 2nd, y to the 4th. The lowest power comes out as the common factor, so y squared. So I divide it in now. 10 just comes down, because I didn't use it. X into x squared, take 1 from 2. Y squared from y to the 3rd leaves me the other 1. My sign comes down. 9 comes down. X into x would cancel. I took y squared from y squared, so that's gone. So minus comes down. X into x squared is x. And then y squared into y to the 4th is y squared. Mentally check yourself. Nothing common to all of these. These have x's and y's, these two, but this one doesn't. So you're good. It would have to be common to all of them. Okay, this next one. I have 12, 6, and 18. 2 is common. 3 is common. 6 is common. You want to make sure you get that biggest number you can get. So it is 6 in this case. I have x squared, x to the 1, x to the 4th. The lowest one comes out, so that's an x to the 1. I have y to the 3rd, I have y to the 1, and I have y to the 2nd. The lowest one comes out, that's a y to the 1. And I divide. 6 into 12 is 2. X into x squared leaves me x. Y into y to the 3rd, take 1 from 3, leaves me y squared. Minus 6 into 6 is 1. X into x cancels, took it out. Y into y cancels, took it out. This 1 absolutely must be there. Absolutely. There's no variable left to hold its place, so the 1 must be there. Plus 6 into 18 is 3. X into x to the 4th is x to the 3rd. Take the 1 from the 4. And then y into y squared leaves me y. Now, if you forget to put the 1, give me 1 second. If you forget to put the 1, you'll notice when you check that you don't have it right. Because let's say you didn't put that there. When I go to check, multiply and get 12 x squared y to the 3rd. And then when I go over there, I'm going to get my 18 x to the 4th y squared. But this doesn't show up. Okay, so that's why checking it will hopefully help you remember that 1 there. Yes?
So when you're finding the exponents, it's like what?
You look at all the powers of all the x's, and whichever is the lowest is what you take out. So y to the 3rd, y to the 1, y to the 2nd. They all have a y to the 1. Some of them just have more than that. Okay? Did I have one up here? Like on this one here above there, I had a y to the 3rd, a y squared, and a y to the 4th. So you take out the lowest power is what's common. Okay? So if you kind of look at it like this, I know I'm using a lot of explanation here, but so when you're looking for common, you're looking what they all have. Well, they all have 2.
That's the lowest.
That's the lowest one. That's why we're taking out a y squared. Okay?
And then the parentheses is pretty much just like what times that would equal.
Exactly. Exactly. Okay, and our last one here, I'm going to talk about only because my leading term is negative. So I'm going to do it like I've been doing it already. So I'm going to look at my numbers. I have 4 and 8 and 2. So I'm going to take out a 2. I have x squared, x to the 1, x to the 1. I'm going to take out an x to the 1, the lowest power. I have a y to the 1, a y squared, and a y to the 1, so I'm going to take out a y to the 1. And divide. 2 into negative 4 is negative 2. X into x squared, so I'm taking 1 away, leaves me x. Y into y would cancel. 2 into negative 8 is negative 4. X into x would cancel. Y into y squared would leave me the other y. And 2 into positive 2 is positive 1. X into x would cancel. Y into y would cancel. Okay? So what I did is I've been doing the same thing I just did, have been doing. Did the same thing I've been doing. I didn't change any signs, okay? So this is exactly what I've been doing. However, you could